Assalamualaikum. Welcome to this Power Word Simulator tutorial. Today I am going to teach you how to perform economic load dispatch in Power Word Simulator software. For this purpose, I have taken an example from the book Power System Analysis by Hadi Sadat, Chapter 7, Example 7.6. According to this example, the fuel cost functions for 3 thermal power plants in dollar per hour are given as below in these equations, where P1, P2 and P3 are the power supplied by 3 power plants in megawatt. We have to find the optimal dispatch and the total cost in dollar per hour for the thermal power plants when the total load is 975 megawatt. With the following minimum and maximum generator limits in megawatt. The mathematical solution of this example can be found in the Hadi Sadat book. For your convenience, I have uploaded the example solution in the form of PDF link in the description section. You can download it from there. Now I am going to perform the economic load dispatch in Power Word Simulator software. Let's start. Just click on this icon to open the Power Word Simulator software. Click on this icon to open a new model. For better visibility, go to the option and click on Draw Grid. Change the grid horizontal and vertical to 2 and click on Draw Grid Lines in order to make them visible. Just look at the example data. We have cost functions for 3 power plants. Therefore, we have to put 3 generators. However, before inserting the generators, we need to put 3 buses in the model. For this purpose, go to Draw and click on Network, then click on Bus and insert it anywhere on the screen. A window will appear. Write here Bus 1. Select this bus as the select bus and click OK. Similarly, repeat the same procedure to put the other 2 buses in the model. As we don't have any data for the voltage, therefore we have just put the voltage as it is. Now we have to put the generators on each bus. For this purpose, go to Draw and click on Network, then click on Generator and insert it at bus 1. A window will appear. Go to Display and click on Down. Now click on Power and Voltage Control. It asks about the generator limits. Look at the example data. It may be noted that the minimum and maximum power limits for the first generator are 200 to 450 megawatt. Therefore, write here 200, again 200 and 450 here. Change this participation factor from 10 to 1. Now click on Cost Function block. Then click on Output Cost Model. Then click on Cubic Cost Model to put the cost function variables of first power plant. For this purpose, look at the example data. The variables for first power plant are 5.3, 0.004 and 500. Therefore, write here 5.3, 0.004 here, 500 here and press OK. Remove this reactive power block and double click on this active power block. Write 1 in delta per mouse click and 2 in digits to right of the decimal and press OK. Similarly, put the second generator and connect it at bus 2. Look at the example data again. It may be noted that the minimum and maximum power limits for the second generator are 150 and 350 megawatt. Therefore, write here 150, again 150 and 350 here. Change this participation factor from 10 to 1. Now click on Cost Function block, then click on Output Cost Model. Then click on Cubic Cost Model to put the cost function variables of second power plant. For this purpose, look at the example data again. The variables for second power plant are 5.5, 0.006 and 400. Therefore, write here 5.5, here 0.006, here 400 and press OK. Remove this reactive power block and double click on this active power block. Write 1 in delta per mouse click and 2 in digit to right of decimal and press OK. Similarly, put the third generator and connect it at bus 3. Look at the example data again. It may be noted that the minimum and maximum power limits for the third generator are 100 and 225 megawatt. Therefore, write here 100, again 100 and 225 here. Change the participation factor from 10 to 1. Now click on this cast function block, then click on output cast model, then click on cubic cast model. For this purpose, look at the example data again. The variables for third power plant are 5.8, 0.009 and 200. Therefore, write here 5.8, here 0.009, here 200 and press OK. Remove this reactive power block and double click on this active power block. Write 1 in delta per mouse click and 2 in digits to right of decimal and press OK. Now we need to connect all these generators through transmission lines. It may be noted that in the example data, the resistance and reactance of the transmission line is not given. Therefore, we assume the ideal case here having zero impedance. Now take the transmission line from here and connect bus 1 and 2. Put the value 0 here. Go to display, change the pixel thickness size to 3 and press OK. Double click on this meter, click on this pie chart option, change the color if you want. I choose blue in this case. Click on total power option and press OK. Write 10,000 here in the MVA rating and press OK. Now we need to connect the transmission line between bus 1 and bus 3. Again take the transmission line and connect between these two buses. Double click on this meter and write 10,000 here in the MVA rating. Similarly, we need to connect the transmission line between bus 2 and bus 3. For this purpose, again take the transmission line and connect between these two buses. Double click on this meter and write 10,000 here in the MVA rating. Now we need to connect the load. Take the load from here and connect it here. A window will appear. It may be noted from the example data that total load given is 975 megawatt. Therefore, write 975 here. Change the orientation to up and press OK. Now we need to put the measurement block at each point in the model. For this purpose, go to field, click on bus field and put it here at bus 1. Write here 1 to represent the voltage in per unit and press OK. Similarly, repeat the procedure to represent the per unit voltage at bus 2 and bus 3 respectively. Now go to field again, click on transmission line field and click here to represent the active power flow from bus 1 to bus 2. Similarly, repeat the procedure to put the active power flow at all points. Now we need to initialize automatic generator control mode for generators. For this purpose, go to field, then click on generator field and put it here at generator 1. A window will appear. Click on generator AGC status and press OK. You will see that AGC mode is activated. If you want to change the color, then click on format here. I choose red in this case, however it is not compulsory. Similarly, repeat the procedure to activate the AGC mode for the remaining two other generators. Now we have to activate the economic load dispatch mode in order to perform the optimal dispatch of generators. For this purpose, go to case information, then aggregation, click on areas, change this off AGC mode to economic dispatch mode. Now we need to find the total cost per hour for this example. For this purpose, go to field, click on area field and put it anywhere on the screen. Click on hourly cost and press OK to measure the total cost. To write its heading, go to background, click on the text and put it anywhere on the screen. Write here total hourly cost and press OK. Change the color if you want. I choose blue in this case. Now repeat the same procedure to measure the total load in megawatt for the whole area. Again bring the text box, write here total load and press OK. Change the color to blue if you want. Last, we have to measure the incremental fuel cost per hour for this example. For this purpose, go to field, then area field and click on select a field. Then from the pop-up menu, scroll down and select OPF/lambda and press OK. Again bring the text box, write here incremental cost and press OK. Change the color to blue if you want. At this stage our model is complete. Now you can run the simulation. For this purpose, click on this run mode and go to tools and click on play button. You can see it has successfully performed the economic load dispatch. Now compare the incremental cost measured by the software with the cost obtained in the example. You can see both answers are correct. Similarly, compare the optimal dispatch of generators answer with the answer obtained in the example. You can see all answers are correct. Finally, you can compare the total hourly cost of the economic load dispatch with the answer obtained in the example. You can see both answers are correct. Friends, in this tutorial I have discussed how to perform economic load dispatch including the generator limits in the PowerWorld simulator. By doing the same way, any power system can be designed in PowerWorld simulator and its economic load dispatch can be performed. I will strongly recommend all of you to take IEEE 9-bus test system with data and try it to build in PowerWorld simulator and perform its economic load dispatch. Similarly, you can design IEEE 14-bus test system, IEEE 30-bus test system, IEEE 69-bus test system and so on. Performing the economic load dispatch of these IEEE systems can be used as an objective for your bachelor degree final year project as well as one of the research objective of your master degree research. That's all for today's tutorial. I hope you really enjoyed this tutorial. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.